The perceptron is the simplest implementation of an artificial neural network. Now, the artificial neural network actually is inspired and modeled after the structure and function of the brain, where we have neurons that consist of dendrites, axon, and synapses, right? That help with firing or passing messages, and fires when there's a threshold that has been met. Now, there are two types of perceptron. We have a single layer perceptron. This is what we're going to be looking at. Then again, this is the objective or linear simple perceptron here is to, again, handle linearly separable objects with binary outcomes, hence used for binary classification. The other type is a multi-layer perceptron, which could contain many additional layers. We call those hidden layers, okay, and could be used for multi-class problems. Now, let's briefly explain how perceptron works. So we have 4 parameters. Here, the first layer here is what we call the inputs, right? So we multiply these input values with corresponding weights for those inputs, right? And this is actually our second parameter values. And then we calculate that and add them together. We calculate the weighted sum, okay? And then we add a bias, right? This bias here, this term bias, it's used to improve the model's performance. Once we have this, it passes through the network, and we apply some activation function. For this simple perceptron layer, we use the step activation function, right? There are other activation functions you could use with multi-layer perceptrons, like sigmoid, ReLU, TANH, and that's beyond the scope of this video. Now, the goal here is to try and predict an outcome. In our case here, whether 1 or 0, whether a patient has a chance of getting diabetes or not for 0. So the y hat here is our prediction. Now, remember, this is a feed-forward network. So how it works, it will do several passes for each of those features, or rather for every training example. Each time goes back and tries to update these weights. Remember, the goal here is to minimize the error between the actual value y and the predicted value y hat. So it keeps doing this during the backward stage, right? So this backward stage is what helps to modify the model's requirement, right? And try to minimize that error. Okay. In a multi-layer perceptron as well, again, you can also implement logic gates like AND, OR, XOR, and this just helps it to handle small and large input, right? In fact, multi-layer perceptron can handle very complex nonlinear problems. All right, so that's just that as far as perceptron is concerned. How to implement that in Python? Again, all this remain the same. The only difference here, we import from the linear module, linear model module, we import perceptron. So if we go here, we can find that under here, linear model perceptron. So we click on this, and we can see we have different parameters that are available to us. So we can fine tune this, the penalty, L1 or L2, early stopping, this helps with overfitting, and so on and so forth. And they provided some additional explanation for that. So because this is a very simple implementation of the neuron, we'll just leave it as it is. We use pandas to load our data frame. We split the data into training and test set. Again, we maintain here the 80-20% split. Again, we make an instance of our classifier perceptron. We call it NN_CLF. I just added this, L1 here just for the penalty, and we can also leave this as default. And then we train this. So again, we'll just pass it through this network, simple implementation of artificial neural network. Again, we use predict on our test, X test, this one that we already split. And then we call our accuracy score. Then we find the accuracy score, the accuracy, precision, recall, and F1 score. As you can see here, what we are trying to look at is the recall. Okay, we want to be as close to 1 as possible, right? We want to predict all the correct or all the relevant, all the patients that were actually diabetic out of all the correct predictions. So this is the objective of a recall. We compute our confusion matrix, and we already have something similar to this. So already we can see our perceptron here does a little bit much better, followed by decision tree. Maybe in another video, we'll see how to use ensemble methods. But before that, we can also see how to apply feature scaling, like z-score normalization on our data set, just to see whether that can also improve some of the performances of the different classifiers.